11.5 is about proving a point lies on a circle, and then we're going to talk about similar circles as well. So your first two problems are your warm-up problems. Try them, pause the video, come back, and check your answers. So for number 1, you should have plugged in 2 for x and then 10 for y. And you would have got yes because 10 equals 10. For 2, remember that's your center. And you take the opposite sign, so it's -5 and -5, and then the radius you squared, so it is 49. Okay, moving on to the first two examples. It says that prove that 2 radical 6 lies on the circle centered at the origin containing the point 5, 0. So, in order for a point to lie on a circle, it would need to have the same radius as the circle. Now, what we're going to do is we're going to do the Pythagorean theorem twice. So if I think about a circle here, it says it's centered at the origin and it contains this point 5, 0. So I'm going to do Pythagorean theorem to figure out what the radius is. Then what we're going to do is we're going to see if this point 2 radical 6 lies on that same circle, and if it does, then that means this line right here would have the same radius as my original line. So in order to prove a point lies on a circle, we have to see if that point has the same radius as the circle. So starting with this 5, 0, so it says it's centered at the origin and then it contains the point 5, 0. So using those 2 points, we're going to find our slope. So we look at our change in y over our change in x. Well, to go from 0 to 0 would be 0. To go from 0 to 5 would be positive 5. So now remember in your Pythagorean theorem, that is your a and your b terms. So it's going to be 0 squared plus 5 squared equals c squared. 0 times 0 is just 0. 5 times 5 is 25. I take the square root and I get 5. What this means is it has a radius of 5. So now what I have to do is I have to check the other side, or the other point. So I'm going to try to prove that 2 radical 6 is on the circle with a center of 0, 0. So you're using the point they want you to prove and then the center. So we have to do this process again. We're going to find our slope. To go from 2 radical 6 to 0 would be 2 radical 6. To go from 1 to 0 would be 1. Or, I'm sorry, -1. And this would be -2 radical 6. So we're looking at where we're going. So 2 radical 6 to 0 would be -2 radical 6, and then 1 to 0 is -1. So again, I'm going to plug those into my formula for Pythagorean theorem. So -2 radical 6 squared plus -1 squared equals c squared. Now, if you don't know what -2 radical 6 squared is, you're going to plug that into your calculator. So I want you to hit parentheses, -2 radical 6, close your parentheses, and then square. If you don't close it, or if you don't put parentheses, it's not going to come out the right answer. So make sure you put parentheses around it. When you do that, you actually get the number 24. -1 squared is a positive number, so it's +1. Well, 24 plus 1 is 25, and then I take the square root, so I get 5 equals c, and remember that's the radius. So what I have to do now is I have to compare my original radius, so this one, and this one. So you see how they have the same radius? That means the point does lie on the circle. So we can say 2 radical 6 does lie on that circle. And that would be my answer. So again, just to repeat this process, we do the Pythagorean theorem for the origin and then the point that we know is on the circle. And then we do the Pythagorean theorem again for the point we're trying to prove. and the origin. So let's try another example doing this the same way. It says a circle centered at 2, 5 contains a point 8, 13. I'm going to say it's like here. So I know that it contains this point. I'm trying to prove that -6, -1 is on this circle. So first one, I'm going to find the radius using these 2 points. So we're going to use 2, 5 and 8, 13. So 5 to 13 would be 8. And then if I go 2 to 8, that would be 6. So those are my two A's and B's in my Pythagorean theorem. So it's going to be 8 squared plus 6 squared equals C squared. 8 times 8 is 64. 6 times 6 is 36. 64 plus 36 is 100. Square root of 100 is 10. Remember what you did, you just found your radius of this circle. So now what I have to do is I have to prove that the point -6, -1 is on the circle. So I use that point and then I always use the origin. So it's 2, 5. So now we look at our slope. -1 to 5 is +6. -6 to 2 is +8. So now what I do is I plug it into my formula, and that would be 6 squared plus 8 squared equals C squared. So I get 36 plus 64 equals C squared. Add those two numbers and I'm going to get 100 equals C squared, which equals 10 equals C, or 10 to your radius. So again, we compare our two radii. Since they're both 10, I know that -6, -1 does lie on the circle. And that's how I prove a point is on a circle. So you use Pythagorean theorem. Moving on, I want you to fill in this chart. So remember scale factor. That was from Unit 7. So if I have a side length of 8 and I have a scale factor of 2, remember you want to multiply it. So 8 times 2 is 16. So we went from 8 to 16. So did it get bigger, no change, or smaller? 16 is clearly bigger than 8, so it got bigger. So I want you to pause the video and then fill out this chart and then try 1B and 1C. So this is what your charts should look like, and then 1B says describe the scale factors that cause the shape to grow. So this is a review from Unit 7. So remember, if the scale factor is greater than 1, then the shape's going to get bigger. So scale factor is greater than 1. In order for it to shrink, remember your scale factor has to be less than 1. So it's smaller than 1. And those are your two rules. So before, we've seen figures that we had to slide, rotate, and reflect. And then we did one where it was dilate, slide, rotate, reflect. Well, this is for circles. So circles are a little bit different. If we want to prove that they're similar, or use transformations to prove they're similar, we only need 2 steps. So our 2 steps are slide and then dilate. And that's it. So those are the only 2 steps we need. So to prove these are similar, let's move the smaller circle over to the bigger one. So if I have a circle here, center is F, radius is 2. My step 1 is going to be slide circle F to circle G. So center F meets center G. So all we did, step 1, slide circle F to circle G. So center F meets center G. My next step was to dilate. So this is where say no to Oreos comes in hand. Since I'm moving circle F to circle G, that means F is my original circle and then G is my new circle. So remember, we say no to Oreos, so that means my scale factor here is 5/2. And that's important because we need to write that in our little proof. So we're going to dilate the radius of circle F by 5/2. And that's how we prove that two circles are similar. So we slide and then we dilate. So the rest of this is going to be your homework. Make sure you complete it and then submit it and check your answers.